Dr. Taylor Manalili received a degree in chemical engineering from Northeastern University. And that's because she wanted to take the easiest possible, undergraduate degree to get into dental school. But then she went to Stony Brook University, where she earned her dental degree as well as her specialty certificate in prosthodontics. She's a full-time clinical prosthodontist here at Glidewell. She's a key part of our team. She provides valuable input to our training and education programs, and she also helps around the lab quite a bit. Okay, so today she's going to give us a much needed update on what is going on in the world of RPDs. So here is Dr. Taylor Manalili with removable partial dentures, understanding your options. It's all yours, Dr. Manalili.
Well, thank you for that wonderful introduction. Let me share my correct screen here. There we go. Does that seem right to you guys? You see that first screen? Let's see.
That's perfect.
Okay. Excellent. Well, thank you for that. And thank you all for tuning in today. I know this is quite a riveting topic for this Friday morning. But like I'm assuming all of you that are here, I do find understanding some of these processes and what our options are goes a long way in treating our patients and knowing how to deal with some of these things when patients come in with either broken prostheses or teeth falling off, glass falling off. So this lecture could go on for multiple days. I know this is a short webinar, so this is, again, just kind of an intro into this topic. If there is a big interest for things that I don't have time to cover today, we can always come back and do an additional exciting RPD webinar in the future. But for now, there are a couple things I want to cover today. So the first thing I want to go over is kind of in this era in today's world of digital technology. We've had a ton of webinars over the last, goodness, we've been doing this for how many episodes? I don't know, but we've done a ton of different webinars on some of the different digital aspects that are now in the dental field and how we're incorporating that. And I wanted to draw a little bit of attention on how that is being utilized in the partial world, right? So a lot of talk on how we're doing complete dentures and obviously crowns and impressions and all sorts of dental materials, but partials haven't really gotten that much love. So I want to go over some options if you have incorporated digital technology in your office, how you can use that. I also want to talk about today how the lab uses that, right? So I think, I know I'm a prosthodontist for a reason. I love this side, right? I love working for Glidewell and seeing the lab side, but I do find it has helped me a lot in treating my patients, right? Understanding how these prostheses are made really helps me make judgments on which prostheses I want to spend the time repairing, which ones we have to go ahead and just cut our losses and fabricate a brand new prosthesis. How maybe we can go ahead and repair or fix some of these things in our office, and when I don't want to waste my time and I know I need to send that to the lab for the use of equipment that I just don't have, right? So I'm hoping to answer a couple of those questions today. And then at the very end, I want to review just how we're going to adjust some of these frameworks. So those adjustments and those things we can do in our offices, how we do that with these different partial materials that are out there right now. So I did identify a few partial materials that we're going to talk about today, as you'll see. Some of them I'm going to name by brand names. Forgive me if I leave out brand names, as some of you know, depending on the labs you use and where you go and articles you read, there's so many different names out there and it's hard to keep them all straight, right? So hopefully I will be able to clarify some of that today. So let's start here. So when you're in your office, we have a couple options, right? So some of us utilize intraoral scanners now in our office, and you can take an intraoral scan for your partials. It's very exciting to say. So you do have the option of doing these digital impressions to capture your initial impressions. You can also do your analog versions if you like. So if you've listened to me lecture before, I'm a big fan. We're trying to go digital wherever we can. And so I tend to try to do these digital workflows as much as I can. If you are not a digital dentist yet, if you do not have an intraoral scanner in your office, do not fret. You can still take your traditional impressions. The lab will accommodate for both workflows. But once the impression gets to the laboratory, in past lectures we've talked about specifically like implants and crown prostheses. A lot of these things get automatically bumped into a digital workflow. So whether or not, Dr. Park and I always talk about this, whether or not you are a digital dentist in your office, a lot of times these prostheses enter this digital world at some point in time, right? So I forget the exact statistic, but it's something like 95% of the cases that come into Glidewell are converted into the digital world at some point. Partials are one of those things that some of them do and some of them don't, depending on the material that you are requesting, right? So when your impression gets to the lab, there are several different workflows. So they either take your digital or analog impression and they create a physical cast, keeping it in the analog world or taking it out of the digital world into an analog world. Sometimes they will take your analog impression and upload it into the digital world, or they will keep it all digital, right? And so I found this kind of workflow and chart, which I find is very straightforward and very easy to follow. And so again, these 3 steps, right? So you either have your physical impression. We've all done this in dental school at some point in time, right? I don't know too many dentists nowadays that survey their own casts, but you can always do that if you wish. I think I donated my surveyor to one of the first year dental students when I left my residency program. But you can certainly survey and design your own cast. If you do not do it, the lab technician can do that for you. And they can have that option of doing it now either conventionally, like on a surveyor, or through a digital software program. And so what that would happen, that falls into kind of that analog digital world where they're going to upload your cast, then digitally design it. And then obviously in a digital workflow, we're going to keep digital and do all that designing based off of the digital impression. And so as you'll see as we move forward, this gets kind of tricky from here, right? So sometimes depending on the framework request from the dentist, sometimes these designs are pulled from the digital world back into the analog, and sometimes they can stay in the digital realm. So I wanted to just review a little bit of the software for those of you that maybe haven't had the opportunity to see it. It's pretty cool where we've come. So just like when we look at teeth preps and designing crowns, we have very similar features when we're designing our partial dentures. So in the software, we can identify the height of contour. So so what's another thing that a lot of us do all the time, maybe much more frequent than partials probably, is something like a night guard, right? We can think about an occlusal guard. So this software is very similar to identifying the height of contour in the undercuts when we are designing and fabricating occlusal guard. So it's going to help us determine what that path of insertion is, right? So the software helps us easily identify those height of contours. We can digitally survey these casts, right? So we can survey the cast, we can move the model around. Really figure out exactly where our undercuts are. We can measure those undercuts depending on that path of insertion. And it really helps us figure out the optimal clasp design and just general design overall, right? So in the software, we can go ahead and add in and really map out exactly where our frameworks want to be. What I love about this, and I will probably mention this again later when we get to it, but it's really consistent, right? So you can consistently figure out the thickness of your material that you wish to choose. Very consistent workflow, right? Where a lot of things we do by hand aren't always ideal, right? So there's that human error, that human factor that comes into play. Okay, I'm getting a little off track. So we design our frameworks, and then from there we have some options. So if you have to still create your rest seats and your undercuts, once the cast is surveyed, the lab technician can send back that information to you and you can go ahead and prep your rest seats. If you have to create bigger undercuts, you can. So sometimes I add composite. Sometimes there's a situation where maybe it's a situation where you want to add a survey crown, a tooth is a little more broken down perhaps. But creating the necessary undercuts to hold these materials in place and get retention for your patients is really optimal, regardless of the material you're choosing. Okay, so if we've already created all of our rest seats and everything is designed the way we want to, and now we're ready to fabricate our framework. So from here we have some options. So one option we have is printing this, correct? So we can go ahead and when we're going to print something, some of you may have printers in your office now. I know they're becoming more and more popular for whether we're printing study models or provisionals or surgical guides, right? We have these options of doing this printing process in our office. And again, at the lab, a lot of these things can be printed as well. And so when we do this, we notice if anyone's printed anything, you have to create some supports. So sometimes we have to create supports on partials. We have a lot of little clasps and little areas that go in and around the teeth, right? So all of those pieces really need to have proper support systems provided for them. You notice on this top picture, we've also created these support bars. So these support bars help prevent the framework from warping or from breaking during this printing process. So the last thing I put on here was we can also send these to the mill. And so again, when you have this digital design process, this digital design framework created, you have these options of these three pathways, right? So we can print something. So 3D printed, we can print wax, which is shown in the middle, which that wax I will review can then be turned into different materials based on what you choose. You also have the option if you ever ask for a metal partial. A lot of times these are 3D designed now, so digitally designed. And then these are 3D printed using a metal printer, which is very cool. And I'll talk about that in a little bit. So the other option you have again is for milling. So these 3D digitally designed frameworks can then be sent to a mill and the framework actually milled out from a solid puck. Okay, so I've mentioned a couple different fabrication methods in here. And for those, some of you may know this already, but a lot of you may not. And I didn't know some of these processes as well as I thought I did until I came to work here at Glidewell. So I wanted to just review some of these fabrication methods today, because again, I find them fascinating and it really has helped me understand how to adjust and address some of the issues that always happen when we have partials, right? Partials are a work in progress, and patients that wear them, they don't always love them. Sometimes they're used for immediate purposes. Some patients, unfortunately, have to use them for the long term, and just helping myself understand how to help those patients a little better. And that's really come down to understanding how these are made now, and kind of help me kind of facilitate how I address these situations in my office. Okay, lights are going off. So there are some basic fabrication processes I want to go over. So the first one, we've all done this a few times, is the lost wax technique, right? I'll briefly review that if jogs some memories there. We also have some printing processes, right? So I talked about printing wax, printing metal. So when we talk about printing metal, there's a process called direct metal laser sintering processes. Sometimes they're referred to as select laser sintering or selective laser melting. We have injection mold processes. We have one of the conventional methods of press packing. And then, of course, we have milling. So a lot of options, but I do find them very fascinating. So I'm going to give some people some PTSD from dental school briefly, right? So let's talk a little bit about this lost wax technique, because it is important in understanding kind of just the timeline and where and how far we've come, right? So when we think about the when we think about this technique, I'm giving myself PTSD, right? So we've probably, maybe, I hope a lot of you have never had to do this for a partial framework, because it is extremely labor intensive, this process. And maybe this picture might be more similar to maybe the experience that you've had in your past, if you've ever had to do this in your dental school. But creating these wax patterns, right? It's very time consuming. Remember waxing out a tooth, making sure it comes on and off your refractory die, spruing it, investing it, sticking your hand in a casting ring, almost getting your fingers cut off, right? So this is it's a very traumatic memory for me. I'm glad I don't have to do this anymore. But think about if you had to do this for a single crown. For a partial, it's so much more intense, right? And so there's so many little pieces of metal that you have to make sure, little pieces of wax that you have to make sure the metal gets to. So when we sprue these, there's multiple sprues. It's a large investment. It goes into the oven. And then there's a huge process of taking this apart, right? So we remember having to polish just a single crown. Imagine having to go through and polish a whole framework. It's extremely time confusing, right? And then on top of that, we can get miscasting. So a lot of times, not a lot of times, but many times, these weren't casted correctly. So this process has to be repeated again. And it's very costly for the laboratory, time consuming for the lab technician. And a lot of times that cost was reflected in what you had to pay to the lab. So I'm happy to say we have moved on from that process, thankfully. And so we've gone on to some of these other options that you see below here. And so I want to talk a little bit about this 3D printing option, because I think it's a very cool option. So we can design these frameworks again in this digital platform, and then we print them. We print the resin. So if you guys use Glidewell as your laboratory, some of you may have gotten printed biotemps in the past. We mill biotemps, print biotemps. We're printing 3D, I mentioned before, the occlusal guards. So there's a lot of dental materials now that are being printed. It's very, it's a great process, right? This additive process of printing. And so when we do this, we print these patterns, but then these patterns have to be made into something else, right? So these printed patterns, it's a modified resin, right? It's a modified resin pattern, not just your standard wax pattern that you're waxing up like you did maybe the conventional method. So it's a slightly different waxy material. So it has to be treated differently. And so things have been invented over time. But basically, as we burn these wax patterns out, it's a special kind of investment. The temperature is slightly different, right? So these techniques it's slightly different, but the end product is the same. So the design process of creating the wax pattern is a little different, maybe a little bit more predictable. You can design it digitally. The thicknesses are more predictable. If you have a miscast, you don't have to go ahead and recreate the whole wax pattern. You can just hit print again, right? But we still have this process of creating the metal framework that still seems a little tedious, right? Still have to go through all these steps. And in the end, this is kind of how we feel about it, right? So all of this is still casting. You can still get porosities, incomplete casting, distortion, surface roughness from this. Overall, it's time consuming, very expensive. So another 3D printing method that I love, and which I find very fascinating, is this direct metal laser sintering. So anytime you order a metal framework from Glidewell now, some other laboratories as well, we're going to be utilizing this process. Okay, and so what this does is it's basically, so it is a printing process. It is an additive manufacturing technique. And so it's using basically this high-powered laser, and it's going to fuse small particles of metal, right, and create this 3D shape. So a lot of times if you go into the lab and you watch some of these technicians doing their work, they're designing a bunch of frameworks and they're laying it out on this build platform. So similar, if you think of if you ever created a bunch of crowns, bridges, and tried to mill them out on a single puck, it's some of the same thing. So they design all these things and they're able to mill out a bunch of frameworks in a much more timely fashion. And so I just have a little video of how this works because I do find this so fascinating. Oh, I thought I turned the volume off. I'm going to turn that off again. Kind of loud. But basically, these machines have been around for a while, right? So these machines, originally the ones that we used to have, so Glidewell's been doing this for a while. The ones that we used to have, they took about 8 hours to mill out or to print out these frameworks, right? So it was one laser that was going through to mill out, I keep saying milling, to print out these frameworks. This newer machine that Jim has acquired actually has 4 lasers in it. Okay, so I'm going to play this video one more time. But you can kind of see these lasers working here. You can see 4 lasers working together to fabricate these frameworks. And it actually only takes about 4 hours to print out all of these frameworks. Very, very cool, very, very efficient process. Okay, so there still is afterwards some post-processing that needs to take place, removing some of the sprues and all of that. But overall, it's a very efficient method. Very, very neat method. Okay. So injection molding. So this is something that has been around for a while. If anyone has had the pleasure of processing their own dentures in the past, this is a process that is used to make traditional conventional dentures. We also use this now to fabricate a lot of our thermoplastic partials. So basically what happens is you have some sort of wax pattern. You can put teeth on these. So you wax up a denture, right? You get your wax try-in for your denture or your partial. This partial is then kind of invested in a flask, and then the wax is melted away and the thermoforming or the resin is injected into its place. And it looks kind of like this. So the wax empties out from one side as the material is pushed through the other side. And so we use this process still today. This is used for a lot of your, or can be used for some of your acetal materials, your polyamide materials. So a lot of those thermoforming materials, right? So this is kind of what these machines can look like. So the wax pattern is placed in it, the wax is dispensed, and then this is kind of the final product that comes out. So still some cleanup to be had at the end, but not as challenging as metal and certainly much easier. Okay. And so this is kind of what you get in the end, right? So we know these nice thermoforming partials that we've all used in our practices. So I want to talk briefly about these press packing process. Tongue-tying myself today. So this process, this is used at times to add teeth to some of these frameworks. So a lot of times, if we're not going to injection mold something, we utilize this press packing process. Still used in some labs today. When I think of this, I think of some of these kind of interim partials that we're utilizing with these clear clasps and our wrought wire clasps. So a lot of times this press packing method is used in these type of partials to prevent some of these clasps from moving about and moving around on us, as like an injection molded technique would. So the last technique I want to touch on today is the milling technique. So milling is kind of, we talked about additive technique before with the printing. This is a subtractive technique. So this technique, some of us may have mills in our office that we're milling our own crowns, certain restorations in our office, maybe even some bridges. So this is utilizing burrs, right? So to do something like this, it's going to require kind of a more advanced mill. So some of these 5-axis milling machines are needed to create these kind of 3-dimensional denture bases or partial frameworks. this process is becoming quite popular, right? So increasingly popular, especially since we've introduced these resin-based polymers, right? So our workhorse, which I'll show a little bit later, has been these cobalt chromium or these Vitalium frameworks, right? These RPD metal frameworks. But now we're starting to see more and more of these polymer manufactured pucks and discs, which are leading to these pretty strong, resilient frameworks that you see kind of depicted here. And generally when they come out, you can see on the right-hand side of the screen, this is what it comes out. This is what it looks like when it comes out of the milling process. So it requires very minimal adjustment from the lag technician, very little finishing when it comes out of the mill. So pretty easy on that end for us, which is nice. So I'm excited to see where that goes as we create more and more materials in the future, right? So one of the things, this is always a clinical lecture as well. I don't like to bore everyone with the lab process, although I could talk about it forever. I do want to talk about just some things for what you need to do after this. So, right, we've created our frameworks for a couple of these. And so you need to try in the frameworks when they come in. So I've worked with a lot of dental students over the years, a bunch of dentists, and the biggest thing is you got to try in those frameworks when they come back from the lab. So whether it's an acetal framework or a metal framework, you have to try them in um, before you set teeth on them. And a lot of times when we utilize these stronger frameworks, we're utilizing them in situations like this, where we don't really have much posterior support. We're relying on the rigidity of the framework and the teeth, hopefully the periodontal sound teeth, to help kind of dissipate some of the functional load off of the tissue. We want to prevent continuous resorption of the ridge. So the first thing we want to do is try in that framework. And I apologize for the grainy pictures in this. It's coming out not so nice here. But really the goal is we want to make sure that the framework seats all the way. There's no rocking. So this is kind of showing what this looks like on a cast. We don't want that, right? So you either need to adjust the framework or maybe either the impression you took may have been distorted. So a new impression may need to be taken. Okay. If the framework doesn't sit properly, you might need to adjust the framework until it does. Either way, it needs to seat completely and passively onto the arch. So the next thing we like to do once I check that the framework seats, I do like to I will go through, I didn't put slides on this, but I like to go through and make sure that especially in distal extension cases, that those are seating correctly. There's enough room for acrylic around them. So I will even go ahead. So in some cases like this, in these distal extension cases, I'll go ahead and take, kind of put some polyvinyl siloxane on either side, kind of encompassing the distal extension in that and actually measure to make sure I have enough room. This is my anal retentiveness. The lab should do that for you, but that is me, right? That's the reason I'm a prosthodontist. Okay, so go ahead and we're gonna add our wax. We gotta take some sort of bite registration. So since we have a physical framework, I do like to do this in a physical manner. So I will get my vertical accordingly, especially if there's no stops or no distal stops, I should say. So make sure we capture that vertical correctly. And then from there, the lab's going to add our teeth and we do our final try-in. And so I mentioned either the injection molding or sometimes we'll do press packing depending on the clasps, if there's additional clasps that need to be added that aren't part of the main framework, right? So I have a couple digressions here. Like I said, this topic could go in so many directions. So one thing I did want to touch upon, because I stumbled across this article recently and I found it interesting because there's very few discussions about this I find on any stage, on any webinar, really, so just kind of how we set up these patients. And it was very interesting. Charles and Brian Goodacre did kind of this great just summary review of the literature that's out there And this is really their consensus statement that they found. So occlusion, when we think of RPDs, it should be, when we set this up and we try in our teeth, we really just want it to be physiologically harmonious with the patient, right? We want to allow the supporting structures to remain in a good state of health, right? That's always our goal. We want the functional stresses to be distributed amongst all of the occluding teeth. There were several authors when they looked at this study that indicated the occlusion in maximum intercuspation, centric occlusion, right, should incorporate basically bilateral posterior contacts. So we want no deflective occlusal contacts, right? So this is a partial. A lot of times we see these teeth that the partial is clasped to. We see these teeth kind of get stressed out over time. So limiting those eccentric forces, right? So limiting these deflective contacts as much as we can on these designs really helps in the long run, helps these teeth, these supporting teeth, stay healthy. So we want to ensure these bilateral contacts, minimal deflective surfaces, right? So that balanced occlusal scheme when we're in eccentric contacts, right? When there are healthy canines present, so this is important. So sometimes we make these partials and they hang off those canines, right? Those canines are long. They're usually a couple of the last teeth stuck in the mouth, so use them to your advantage. So when we do have those canines present, we still like, if you've heard me lecture on implants, we like this mutually protected, these canine guidance is still a great occlusal scheme to go by. So again, the canines have to be in good condition to do this. And then just like any removable appliance, when we have one arch that moves around, so we have a complete denture opposing even a partial denture, right? We want to try to create a balanced occlusal scheme that the patient will try to avoid those tipping forces. So I do encourage bilateral balance, and they, this study kind of agreed with that. So creating that occlusal scheme for those situations. Okay, so I want to review our material options today with our remaining time, and then go over how to adjust some of these materials, because that's probably what we've all come here today to look at. So as patients, so as dentists, we've loved these metal frameworks for years, right? For generations, this has kind of been our go-to material in some way or another, some form or another, these metal partials. Patients don't like them, right? They don't like the look of them. We've all been there where we've had a metal clasp in the anterior. I had someone come in for a consult earlier this week. Someone made her an immediate partial, and she hates it. There's wire clasps right down her central incisor. She can't stand it, right? So we all know that patients do not want this. There are some, there are some options out there. And so the development of these high performance polymers, there's some aesthetic advantages. So obviously, these are partials. There's only so much we can do. But in a patient's eye, this goes a long way. Maybe not in our trained eyes. This still might not be the most aesthetic thing in the world, but to our patients, instead of having the metal there, having either a clear clasp or these polymer clasps on the lower, they don't quite match the tooth structure, but in today's world, a lot of these polymers come in various shade options. So we have the option of picking a shade that actually comes close to matching the patient's tooth. So this can actually blend in fairly nicely now. And so these are kind of the basic options that we have. So some of these are broken down into, there's a lot of brand names on the market, but these are the general categories that we need to concern ourselves with. So we have our metal framework. So those that are now, if you send in for a metal framework for Glidewell, these are the ones that are being 3D printed in that printer that I showed earlier. These are your chromium cobalt frameworks, right? So these are those if you ever prescribe like a Vitalium framework. So that's a mixture of this, right? So your cobalt chromium, these are they're very high in strength, right? We've been using these forever. They're heat resistant. They're fairly lightweight, right? This material is very lightweight. They're very favorable resistance to wear, corrosion, staining, right? So these have been kind of that workhorse for a long time in the partial world. There's some talk when you go through the literature, I don't have it on here, but of titanium, right? It's a very biocompatible. It hasn't really come about too much. Part of that is just the 3D printing of this cobalt chromium material is so much easier to accomplish, and creating a framework is very labor intensive, even on the mill. So if we were going to mill titanium, all those details, it's very labor intensive on a milling unit. So printing these is still the preferred method of getting your metal framework right now. We've also seen these acetal frameworks. So these frameworks are these are becoming very popular now, right? So these are high strength, they're fracture resistant, they're heat resistant, they deflect stress well. They are also kind of flexible, which is very nice. And they also come in various shades, so you can eliminate the metal aspect, right? Then we have our polyamide materials, which are kind of your nylon materials. So these are going to be, they're fairly high strength, heat resistant, fracture resistant, and they have significant flexibility, which can be a downside, and I will talk about that. And then we have our PMMA. So these are your polymethyl methacrylates. These are going to be kind of your immediate or temporary, we call these like acrylic flippers. Sometimes you can get the clear class made of these, which is great. And then we also use PMMA with some of our other materials, right, in combination. So sometimes we'll use PMMA in combination with the acetal framework, in combination with the metal frameworks, right? So some of these can be combined. It gets really fun, right? So these are, this is a Glidewell study club. So I kind of went over some of the Glidewell products that are out there, right? I mentioned earlier, there are so many brand names and products we can use. Some of these are very similar formulations. We probably all have our favorites that we use in our office. But these are the basic offerings that we have. And you can kind of, I broke it down into kind of the materials that they are, how these are made, and just kind of how we can design these, right? So how these are done currently in the lab. So when we do a PMMA, an immediate, like a flipper, or we do some of these thermoformings, currently, these are still being conventionally waxed up. I have a feeling very soon these are going to be some form of printed resin, like I mentioned earlier. Our acetal frameworks, I'm going from right to left, which is not what you ever do when you're when you're reading a slide, but I am, so I'm sorry. When you're doing these acetal frameworks, right now these are being digitally designed and milled. And then for all of our metal frameworks, these are being digitally designed and printed, as I showed earlier. And then these milled and printed are then being injection molded to add in all the teeth. And so everything in the end is getting that injection mold process, and or sometimes the clasps are gone through that pressed process. Okay, so these simply, we call them simply natural, but they are these cobalt chromium frameworks. Again, so these can be that Vitalium framework. So it's the cobalt chromium, and then I can never pronounce this last word. I'm a chemical engineer, and there's some words I still can't pronounce. Just, the eyes don't match the lips sometimes. So so there's some various metals that accompany that, but these now are printed. So we have our acetal, running out of time. So our acetal frameworks, again, these are milled. So these are these resin-based partial dentures. These are made from this. It's a copolymer, so it's a semi-flexible. When they're thin, so kind of in the clasp form, in the clasp areas where these are thinner, you get more flexibility. And then the thicker this material becomes, the more rigid it is. So in This is great for full frameworks, right? So you can, in the areas where you need more rigidity, it has that ability to be more rigid. So we use these, they do not absorb water. Very, very little water is absorbed in these. So you don't really get a lot of staining on these, which is very nice. Again, you do need adequate thickness. So ideally you need about 2 millimeters of thickness for them to be pretty rigid, right? So one thing I don't have a picture of, but I do want to mention, so sometimes people use these with like an overlay. So if you're ever going to add teeth as an overlay with this, um, the lab does like to have a minimum of 2 to 3 millimeters of thickness for that overlay not to break. So keep that in mind as you're designing these out. This is becoming a much more popular material. So just forwarding that information there if we do want to use it. These flexible partials, they're so popular and I think it's great. There's a lot of options out there. Just be very careful on the situations that you use these in, right? So these are thermoplastic. These are the ones that are injection molded. When I talk about these polyamides, I'm talking about the most common name is Valplast, right? So Valplast, TCS, we have our Duraflex, your Flexite. So there's a bunch of them on the market out there. But these are all these nylon resin based materials. Your Duraflex is your ethylene, propylene, I believe is what it is. A lot of names here. Trying to keep them all straight, right? And so with these materials, they don't necessarily need to be as thick, right? They are flexible material. So generally they're like about 1 millimeter, 2 millimeters in thickness. In the posterior, so these are great when areas where you have like limited interocclusal space, right? So you don't need a lot of thickness. Something like the Duraflex material, they say you need about 3.5 millimeters of tooth thickness plus about 1 millimeter of the actual material, the Duraflex material thickness. You're looking at about 4 to 5 millimeters of thickness interocclusal. So if you have limited space, these are really, it's a nice option for your patient. Um, just be aware. So because these are so flexible, a lot of times over time, this is gonna break down the periodontal support of those surrounding teeth. So one of the things with this material, because it flexes, you don't really have the advantage of creating these rest seats like you do with some of these other framework materials like your acetal and your metal, right? So because of that, you're putting a lot of stress on the tissue itself. The stress is not being distributed properly to the teeth. So you do get a lot of breakdown of the periodontal support. Again, sometimes limited space, limited funding from patients, these kind of are your options. Um, we can also utilize this material itself, can be utilized as clasps on some of your other, so it can be used in combination with some of your metal partials if you wish to change out some of the clasps to some of these materials. So you can kind of mix and match some of these materials also, which is kind of fun. One of the other categories that's listed on the website for Glidewell, one of the offerings that they have are this is the picture that they have, but it's basically your like a flipper, your immediate provisional. So they call these the clear flip PMMAs. So it's basically a PMMA material. They have these different acrylic clasps that can be made into them, or the wrought wire clasps can be put on top of these. And again, so these are more of that PMMA material, so it can be treated just like a denture. And that's how we can repair. These can be relined pretty easily chairside, adjusted very easily chairside. So again, these are nice for immediates because we do sometimes need to reline these as we go. I want to talk a little bit about adjustments, right? So how do we adjust these? We have a few minutes left. I'll try to run through this. So when we look at the metal framework, so this is something I hope you guys all take home. If you take anything out of this, take these last few slides out of here. So when you are adjusting metal clasps or any clasp on a framework that you can adjust, do not use a 3-prong plier. So a 3-prong plier, what happens is you wind up creating a dent in the clasp arm, And then over time, if you have to make multiple adjustments, you're actually going to wind up snapping that clasp off. So what is always recommended is using like a bird bleak or a two-prong plier, like the one shown on the right here, to gently adjust that clasp. So it will not put an indent in the clasp, but instead it will open or close the clasp as needed. So these acetal frameworks, so the same thing can be used, but one tip here, you want to heat the plier. So I like to heat the plier a little bit. I don't like to flame or heat the partial directly because you can actually burn the material. So I do like to heat the plier itself and then apply the warm plier to adjust the clasp as needed. As you get into some of these thermoplastic materials, hot water is always recommended, right? So getting a hot water bath ready. So hot water for about 1 minute, they say. Pull it out of the hot water, let it cool till just about the temperature that's going to be okay to not burn your patient's mouth. You're going to gently insert that into the patient and allow the material to adapt to the tissues. Okay, so this material can be nicely adapted. Again, if any of the clasps are too tight, you can do the same thing. So if the partial fits nicely as a whole, but one clasp is too tight, you can dip that clasp into hot water, and then you're able to kind of move and bend that clasp accordingly. So one of the things I do love that the denture department here at Glidewell does is if you order a couple of these materials, they do have some insertion and adjustment technique guides that they can send you. And so one of the things they recommend, and I use this when I use this material, is the type of burr to adjust. So not all of these materials should be treated the same. So as we adjust these thermoplastic materials, these fine green point burrs come in handy for adjustments. So the harder you press with these, the more material will be taken away, the lighter will you press, the smoother you can smooth this out, right? So again, these are not acrylic, so do not use acrylic burrs on these, right? If we need to smooth these out, if it's still a little rough, you can use some coarse pumice for the roughness, and then you can shine it for that high glossy look. So something like a Duraflex, so it's not quite a nylon based, it's that polypropylene that I was talking about before, right? So these, again, you can use the same green point, but you can also, this actually grinds a little bit more similar to an acrylic, so to a like a PMMA material. So you can use your carbide burrs on these if you'd like to. So that is a nice adjustment. So one of the tools that I love, Dr. Bender and I were talking about this yesterday, is using Fabuluster. It's something that is just a handy tool to have in your office if you do any of these partials. So if you make any adjustments, it's a quick way to give just that brilliant look back to that brilliant shine back to these partials. Another tool, if you don't have a lathe or the access to a rag wheel in your office, Brasseler sells these chair side felt wheels that you can attach to your chair side nose cone, and you can do this chair side, helping you kind of create this luster or this high shine that you want. And so I think I'm ending hopefully right on time. And so this is the overall summary chart of kind of what we talked about today, how you adjust these materials, how these materials are made, and just I think having that understanding of how each of these is made kind of helps me determine how I'm going to fix some of these and which ones I want to tackle chairside and which ones I don't. So with that, thank you. I will hang around for a few minutes if anyone has any questions. Dr. Park, you are on mute, I believe. You're still muted. I'm going to stop sharing.
Okay. Yeah, we had, judging by the huge number of questions here, we had a lot of interest. So I'm just going to jump right into it. When you're talking about these flexible nylon resin-based partials, the TCS versus the Valplast versus the Duraflex, are they the same, or is there one that works better in a specific situation?
Yeah, so it's funny, like when you look into the science of it, I don't know how much I should really say on here history-wise of some of the materials. But a lot of them, when you get down to the nitty-gritty, a lot of them are kind of the same base material. So they're just kind of advertised by different companies, and kind of different brand names kind of took them over. So a lot of them act very similar. Most of these thermoplastics are similar. You talk to different people, it's like anything we use. Some people just have a preference for certain materials. In general, I think it's just important to know the category of thermoplastics and how they act in comparison to, say, an acetal framework versus a metal framework. So I think just in general, these thermoplastics you don't have the ability to really create the proper rest, kind of guide planes, these supporting structures to help distribute the forces correctly, right? So a lot of times what I see in these patients that wear these for long durations of time is just the periodontal support on these teeth that are clasped with these are just in horrible shape. It really puts a lot of pressure on the tissue instead of distributing the forces, tissue and teeth. So I think that's kind of the main
Right.
takeaway with these.
How about,
I
because I have a lot of questions here about which of these materials are repairable, and in which of these materials can you add a tooth if the patient loses another
I
tooth?
know. And Dr. Bender and I were talking about that. I figured there would be a ton of questions on this. And it might be something I put together another webinar to go into a lot of these details, because it can be very confusing. There's a lot of different techniques. In general, as far as clasps go, so if clasps break off, kind of any of these frameworks, really depending on where the clasp is. I'm never really repairing these clasps in house. So kind of the only time I'm going to repair a clasp in house is if it's an immediate. So like one of those PMMA partials where I'm going to add, say, a Rottweiler clasp back
Easy
to
for
it.
you to say.
I know, right? I can't say that. That is something I may want to process chairside or in my own laboratory. Other than that, so like a metal framework, that's going to be sent back to the lab and they can repair that. They basically laser weld it back on. Something like an acetal partial, they're not really going to repair that more than they're probably going to mill a whole new framework for you. And same with some of these injection molded. So it's really hard to add in some of these materials once they break off.
So that would also include trying to add a tooth, right? That, in other words, conventional acrylics, repair acrylics
It's
are not going to
much
stick to this material.
easier. Yeah. So the acetals, the metals, things where you're at injection molding some of those traditional acrylics onto, it's much easier to repair chairside using like composite, things like that. Dr. Bender and I were talking yesterday, and she's saying she's used some composite materials, like drilled some holes into some of these thermoplastics to try to get teeth to stick. And over time, eventually they just kind of fall out again. So it is kind of just a temporary fix. And we were talking, some of these patients, they don't want to go without their partials, and we understand that.
Right.
And so
Exactly.
while we're making another one, it is a temporary fix. You can use some composite, some chairside acrylic to put them on, but they are not a definitive
All right. So I'm going to put you on the spot here as a practicing prosthodontist.
fix.
What are your partials? What are you using metal frames or using flexible?
Yeah, so I tend to I'll be honest, so I do like the idea of having, I've mentioned this more than once now, so you can probably see where I'm going, but having the idea of rest and distributing those stresses accordingly. So I do use metal partials. I have started to use some of the acetal partials a little bit. So one of the things with the acetal partials is you do need a little bit more thickness to get some of the retention and to prevent some of these clasps from breaking. So they might look nicer to the patient, but they might also feel a little bulkier. So it just really depends on the situation, how I feel that patient's going to tolerate it, which one I'm going to utilize. But I do like the option of those a little bit more than using the thermoforming materials. I did mention in areas where there's very limited space and patients have limited finances, um, patients like older on in years, things like that, where maybe I'm not looking for a longevity of a prosthesis, but kind of a temporary fix, then I will utilize a thermoform material.
Okay.
But that's kind of a rare situation for me personally.
And I mean, I think you've mentioned, I have a question here about, do resin clasps function the same way as metal clasps? I think you've made it clear that they really don't, right?
They
There's a
do
different,
not, no. And so undercuts are really important. Again, limited time in this webinar, but they are different. So certain materials require more of an undercut than other materials. So a lot of the thermoforming materials, you need a much greater undercut for them to be retentive than you do, say, a metal clasp. And
is that a
so
situation where you might put a little composite dot on there?
100%, yeah. So
Yeah.
especially if it's a temporary, I'm not going to go ahead and make a survey crown for that patient, or add, but just by adding a little composite helps to keep that
I like that.
retention.
I like that.
Yeah.
Okay, so why do the clasps on this is really, it's two questions from two different doctors, but they kind of answer each other. So the one doctor says, why do the clasps seem very thick? They're very thick, they're very tall. And then I've got several people that said, gee, these clasps seem to break. So I guess that's the problem, that they have for these flexible partials, the lab has to design them with thicker, broader
Yeah,
clasps to keep
yeah,
them more resistant. Otherwise they break.
exactly. And I think we have to be very mindful when we use these thermoplastics. Is kind of a lot of people, I've seen some designs in the labs where people request these and they're replacing every tooth in the arch except for 2 teeth with these thermoplastic partials. You're setting yourself up kind of for failure when you do something like that, because you're really you're going to get, one, a lot of resorption of the arch, and your the remaining teeth are really going to break down. And we can argue back and forth forever that
Study club.
Someone told me once a long time ago, just a partial is just
She's
something,
answering
a slow
questions.
extractor. Andy, I think your mic is on. I don't know how to mute you.
Yeah.
I'll turn it off. Sorry.
Thank you. Yeah, so in general, I think partials are always harsh on the supporting teeth, but really picking and choosing the materials you're using based on the situation is very important. So I think replacing a couple teeth where you have multiple teeth you can clasp onto, and you're really, if you don't have the ability of rest, really using your clasps and hard palate, using some of those stops to help prevent some of the resorption is very important when using these thermoform materials.
Yeah.
And bulk, right? Material thickness is huge. So if you're using these, just be mindful the material does have to be a little thicker. So Duraflex is one of those materials that can be a little bit thinner. I mentioned before, it can be about 1 millimeter in thickness, but just be mindful. I mean, I've seen those break as well. So they do claim it can be about 1 millimeter, but you really need to have adequate thickness for them to not break in total.
Great, that's very helpful. This is an interesting question, and I'm not familiar with this whole issue. Can you speak to PMMA frameworks and risk during pregnancy? Have you heard anything about toxicity like that?
That I've had that asked, not specifically about PMMA, but some other materials, and I don't know 100% the answer to that. I have heard other people have concerns with just like the brief literature search I've done. I haven't seen anything. So part of that is just it's more the monomer
Right.
kind of leakage. And so I don't like to process any of those things in the mouth. So like relining PMMA, doing things like that intraorally. I think we were talking about this even yesterday, Dr. Park, is like, we don't ever really know how that affects the epithelial tissues in the mouth, right? There's very few research papers, if any, that have really been done to see how the flora and all that changes and affects the tissues in the mouth. But I will say, leaching monomer in the mouth is not good. So I would say anytime you're gonna reline something, take an impression, do it on a cast outside of the mouth if they're pregnant, Water baths really help. So tempering, if you rely on a material, PMMA in a water bath, will help kind of cure and diffuse a lot of those monomers and prevent that from.
And I think that's a great point. And a lot of times, as you said, the monomer is the risky material.
Yeah.
So if you can do something like, milling from a PMMA puck, well, that's less likely to leach,
100%. Yeah.
or something that's been
I'm thinking
injection
lines of
molded.
repair, but yeah, absolutely.
Right,
Just
exactly.
fabrication in general.
But yeah,
Yeah.
there is a lot of research that needs to be done on those things.
Yeah.
Okay, I'm going to ask you the last question, and it is a philosophical question.
Okay.
When is a partial denture not a good option? And specifically here, this doctor's talking to a type of case that you've alluded to too, where maybe they've got a lower cuspid and then a couple of remaining anterior incisors. They can't afford implants or an overdenture. I mean, is it better to put a partial in there that's going to do some damage, or to just leave them without teeth?
Yeah, and so that is always a question. And I find I struggle with that as well, right? We all it's a judgment call, I think, and I think it really comes down to interviewing the patient. I had an attending once that used to call it, it's sad to say, but the wallet biopsy too, right? And sometimes patients, sometimes they're very attached to the teeth that they have. We all know this, right? We don't want to edentulate someone. I mean, unless we have to. So sometimes I will do, especially if they are very hesitant at first, it's a progress. They might get a partial, they wear that for a few years. They understand what's going to happen, right? So I'll always tell them the risks involved. If they're at all hesitant financially and or emotionally, a partial is a great option. Just tell them what's going to happen over time so they're not caught off guard if their supporting teeth do start to break down. And
I
they
mean, is there a
may,
point where
yeah,
a partial on 3 bad teeth is not as good as a full denture?
yeah. I mean, I'm not going to put a partial on like mobile teeth if that's what you're asking, even if they are attached to those teeth. So if anything is unhealthy in the mouth, I'm going to take it out. If they are solid teeth, I, I'm a big implant advocate, but I'm also an advocate of teeth, right? So we like to be conservative where we can. If the patient has been functioning like that for a long time, and the teeth are distributed in a way where they're going to lend a support system to the partial, right? So they're not just like 3 anterior incisors. That's not going to help me any. But if they're distributed, as say it's 2 molars and a canine, then I might utilize that to my advantage to make a nice stable partial for that patient. So it's really going to come down to kind of where those teeth are in the arch, the stability of the teeth, and just the patient's mindset is a big factor too in doing that.
Very good.
I don't know if that really helps or not, but
no, it's a philosophical question, and it's
yeah,
you have a choice of several bad options.
it is.
And you just have to choose the best of the bad options. And
it is.
that's,
And denture patients are always just, as we know, just the most fun, right?
Well, very good, very good. Well, thank you so much. I mean, there's so much going on in this field. There's so many more options than we used to have. Thank you for taking the time to break it down for us. You showed a couple of great charts. For example, one that showed all the different materials, and then you showed one that was how to adjust each different material. Can you make those couple of slides available to the folks?
Absolutely. Yeah, I will give that slide to Nicole. I think I have one final summary slide, so I'll give that to Nicole and she can distribute it.
Fantastic. Well, thanks, Dr. Manalili. We appreciate it. And thanks to the panel, and thanks everyone for joining us today. And be sure to join us next Friday when we'll stay with this theme of removable prostheses. And we'll have Dr. Patricia Swanson from Stony Brook University, and she's going to join us to help us simplify complete dentures. Oh my goodness, I can't wait to simplify complete dentures. So thanks everybody for joining us. We'll see you next week at the same time. Thanks everybody.